Probability with biased coin. Here is a twist to our simple problem of tossing a coin, which we assumed to be fair coin, right? Now we are playing kind of with unfair coins. And we'll explore this example with the help of a tree diagram. The question here is, a coin is biased so that it has 80% chances of landing on heads. If it is thrown 2 times, find the following probabilities. So the first one is probability of getting heads and heads, and the second one is probability of getting heads and tails. Now let's look into it, and we'll take the help of tree diagram to solve this question. So let us say we throw the coin first time, then what is the possibility? The possibility is we can get heads or we can get tails, right? Now let's throw it second time, then what are the possibilities? The second time also the possibilities are that you could get either heads or tails, correct? Heads or tails. So that completes our tree diagram. But here is a very interesting twist, and that is coin is biased so that it has 80% chances of landing on heads, right? Now 80% chances of landing on heads. It means what? It means that if you throw it, then the probability of getting heads is 80%. So this branch has probability of 80%. I can write this as 0.80. That gives you probability of getting heads. Now if probability of getting heads is 80%, what is the probability of getting tails? It should be 20%, right? So 0.20. Since the combination of probability is always 100%, right? So every branch has this kind of a weight. So we have different weights here. Now answer the question. Is it equally likely to get head and tail? Or we get finally these combinations, head, for example. So we get a combination head here. The other combination is head and tail. And this one is tail and head. And the last combination is tail and head. So these are 4 combinations. Are they equally likely? That is the question. The answer, is not. Do you understand? So they are not equally likely, right? Not equally likely. Now, since they are not equally likely, we cannot write our answer like probability of getting head and head is 1 out of 4. Do you see that? Or probability of getting head and tail. It means when we write head and tail, it means head, tail or tail, head. Both combinations, right? That means these two. So it is not 2 out of 4. That is first thing you should recognize. Now we cannot use those kinds of ratios since the outcome is not equally likely, right? So that's first thing which you should understand, right? So that is what it is. And second, it is a compound event since we are doing 2 trials at the same time, right? 2 events in this particular question. Now let's move on with this question. So what you've understood here is that it's a biased coin, right? Therefore, whatever you get is not equally likely. It's more likely to get heads and 80% more likely to get heads, right? Now, as we move on this branch, next time, this is for the first row, right? Next time when you toss your coin, at that time, what is the probability of getting head? Well, it is an independent event. The situation remains the same as the same coin. So basically, this is a case of an independent event. And here also, the probability will be 80%, right? So this will be 80%. And for getting tails, it will remain as 20%. So it is 80-20, right? So that is the ratio in which it works. Now, what is the probability of getting heads and heads? So there's only one combination which gives us heads and heads, right? So that is the combination. So to get heads and heads, we need to get head first and then again head, right? And we get head and head. So what is the probability of getting heads and head in this case? So to find this probability, what we do is we multiply these two, right? So it is 0.80 times 0.80. That is what we get. So 8 times 8, 64. So probability of getting head and head for us is 0.8 square you can write, or So I'm writing 0.8 square here for the purpose. 0.8 square or 8 times 8 is 64, and now decimal place should be after 2, right? So it is 0.64. That is the probability, or you can say 64%, correct? Now let's answer the second question, and that is, what is the probability of getting head and tail? When we write probability of getting head and tail, what exactly we mean? We mean probability of getting head followed by tail, right? Head and tail, or probability of getting tail and head. Do you understand? I mean tail and head. So that is what we mean when we write head and tail, right? Irrespective of the fact which came first, right? Whether it was head first or tail first, end result we are interested in head and tail. That combination, right? Remember that part. That means this time we are looking into these two solutions. So solution number 1 is this, and solution is 2, right? Head, tail, tail, head, right? So what is the probability for these two combinations? If you go through this path, that means first you get head and then you get tail, then you have to multiply 0.8 with 0.2. So you get 0.80 times 0.20, correct? On the other hand, if you want first tail and then head, then you get 0.20 times 0.80, correct? So these are the two answers which you could get for head and tail and head. Now, or in probability means addition, right? So you can write this as 0.80 times 0.20 plus, or means plus here, right? 0.20 times 0.80, right? So this is the same thing. 8 times 2 is 16. So we get 2 times 0.16, that is equals to 0.32. So 32% chances are that you get head or tail, right? Head-tail combination, correct? So that is our answer. So our answer is that probability of getting heads, both heads, is 64%, and probability for getting head and tail, which also means tail or head, is 32%, right? So that is our answer, right? From here you can always find what is the probability of getting two tails, right? Which is 1 minus this minus 32, right? So that is how you can solve this. Or you could just multiply 0.2 with 0.2, you get 0.04, right? 2 times 2 is 4, right? But 0.04, that is, or 4%, right? 4% is left when you see here, right? That is 4% is the probability of getting two tails. Remember that, this times this. So it's just 4% to get two tails for this particular case, right? I hope you understand and appreciate this question. Now, as an exercise for you, what we will do is, we'll give, this is your problem now. Your problem is to do the same thing with the same biased coin, which is 80% chances of landing on head. If it is thrown, instead of 2, let me make it 3 times. Let me make it 3 times, right? So we throw it 3 times. And in that case, find probability of getting 3 heads. This is the first case. Or probability of getting head, head and tail. 2 heads and 1 tail. So to answer this question, try to do it once again. That means you need to extend this, correct? Extend it one more level and get your answers. Now you'll realize importance of this. So when we go to 3 heads, it will be Q. Do you see that? And then you can correlate all other answers in a similar fashion and kind of get a pattern so that you understand, if I make it not 3 but n times, then what is the answer, right? So that is your next level of thinking. So you can think in those terms also, and those of you who are interested can even go for n times, right? And come out with some answer. That should be interesting. I hope you enjoy, and more important, understand what is the probability of cases when we are not dealing with equally likely terms, right? Then you just can't have total number of outcomes divided by favorable outcomes. That thing doesn't work now, since these outcomes are not equally likely. Okay? So, kind of important for you to understand the term not equally likely when we are dealing with biased coins, right? So we'll have few more examples which will be not equally likely, where you'll find the only way to do it is to multiply the individual probabilities and get to the answer. Okay, thank you.